Hi, welcome to Cloud Cover. My name is Ryan Dunn.
And I'm not wearing any pants.
Hot dog!
This week, we're going to be covering the diagnostical capabilities of Windows Azure. And yes, I did say diagnostical.
I'm pretty sure it's a word.
I am going to coin that. It is now diagnostical.
It's official because he did this.
Yes. Well, once you click on the desk, it's pretty official in all ways.
Exactly.
So we're going to be covering the diagnostics capability within Windows Azure, talking about how it works and some tooling that you can use to actually monitor and manage this yourself. And the news as always, and we will round it out with a tip on some common issues you might run into when running the diagnostic monitor and how to troubleshoot those. So with that, let's swing over to the news.
So the first thing we have is over on Amazon.com, you can buy a copy of Programming Windows Azure: Programming the Microsoft Cloud. If you ask me, a redundant title, but it's about Windows Azure. It's written by Sriram Krishnan, who is a teammate of mine on the Windows Azure team. So he might know what he's talking about.
I'm going to go with probably.
I haven't actually read the book, so I have no idea how good it is, but I did write a blurb on the back that says how awesome it is.
Wait, so you wrote a blurb about saying the book was awesome without actually reading the book?
I may have read a little bit of it, but the important part is that I wrote a blurb on the back. And so
the moral of the story is never trust reviewers. Apparently.
That's good. The blurb is awesome.
So we should actually go buy this book just to read your blurb.
Just to read the blurb.
Yeah.
But also to learn about Windows Azure.
Okay. Well, that's fine.
It's just secondary.
If you were actually going to go purchase this book, however, and you happen to purchase it from Amazon, Steve and I have a suggestion, which is you might want to pair that with, yes, the infamous 3 Mountain 3 Wolf Moon short sleeve tee.
Well said.
Yeah.
This does go great with the book.
Well, I have found that when I wear my shirt, that I actually read a lot faster. I find that I think it's the wolfiness, the capabilities of the wolf to sharpen my eyesight, and I tear through technical novels in about half the time. So if you are going to get a Windows Azure programming book, and they can be very dense, Steve and I highly recommend the Wolf t-shirt to pair with it.
Yep, I retain more knowledge also.
Yeah.
I read faster, remember more.
Yep.
It's good for any book, but especially for programming Windows Azure, programming the Microsoft Cloud.
Yeah. Moving along. We have a developing and deploying with a SQL Azure white paper. Now this just came out from the SQL Azure team. It's guidance on just what it says, how to develop and deploy with SQL Azure. So really some great work that they've done in here. Very useful white paper.
Yep.
Highly recommended.
Especially about if you've got SQL Server going and you're trying to get the SQL Azure going. This sort of takes you through, what do you have to do? What are the tools that you can use to connect up, get things started, and whatever. So very good. Check it out.
Yep. Recommended. Stamp of approval. We need a stamp of approval.
We do. That should just appear every time we recommend something.
Yeah, big stamp.
All right.
All right. Now we've talked about this before. It is the WAG.
WAG.
With 2 A's. Windows Azure Architecture Guide, Part 1. Now this has been delivered in Silverlight form, so it's essentially an ebook that you can go out to and start reading right now.
Yep.
And what's kind of cool about this, in addition to the fact that it's just great guidance, is that this little Silverlight application, if you notice up in the URL, is actually being delivered directly from blob storage. It's guidance.
Cool. It's like meta. It's
yeah,
like
it's guidance about itself. It's like when you write a compiler that can compile itself.
Yep.
It's that awesome.
That's pretty awesome.
Yeah. I bet you they use best guidance practices to deploy this.
It's just
like
a bunch
upload
of blobs. Upload it.
That's great.
Next up, good news. The Windows Azure CDN used to be free, and now you're going to have to pay for it. No, the good news is really that it's out of beta and it's production ready, and with that does come costs that are starting, I guess, July 1st, or what does it say here? After June 30th.
I'm going to go with July 1st.
I'm going with there's some legal reason why those two different dates are different.
Because if we somehow were able to skip the date July 1st, then in theory it would be free.
Well, 2010 is a June leap year.
Yeah.
So there's an extra
well, some
day
countries don't actually recognize the 1st of June.
1st of July.
July.
Yeah.
Yeah.
They just go straight to the second.
You're straight to the second.
So this is good. So pricing will kick in, which means this is your opportunity this month to still play with the CDN for free if you want to, and decide if you actually want to start paying for it come July. And if you don't, turn it off, because it is just going to sort of kick in automatically.
Yeah, but you look at the pricing here. I mean, it's the exact same pricing as if you're out of blob storage in terms of like the gigabyte transfer rate. So if you're using if you need CDN capability generally, and this is going to be a good deal for you in most scenarios. Now, I know we were kind of talking about it earlier, but some of the scenarios you're saying that this might not be such a good deal is if you're not getting to the cache very often.
Right. If your objects aren't actually being cached because either you did something bad, like set the expiry time really short, or or short time to live, or if it's just very infrequently being accessed and it's just being evicted from the cache because the CDN node is just not seeing demand for it. So if you find that you're missing the cache a lot, then what's going to happen on those cache misses is the user's going to hit the CDN endpoint, which is going to hit blob storage, and you have a transaction to hit blob storage. You've got bandwidth to transfer it to the CDN. You have a transaction at the CDN. You have bandwidth to transfer it to the user, and so you've actually doubled some of those costs for the cache misses.
Yep.
For the cache hits, it's, as we were saying, it's basically free. It's free with your purchase of blob storage, in that it's the same price. There's no sort of additional thing. So it's a very good deal for all the reasonable uses of the CDN, but make sure that you're actually using it for something where the cache is going to be effective, and then you're in good shape. I actually believe that the bandwidth charges in some parts of the world are actually cheaper with the CDN than blob storage. If you go look at the blob storage bandwidth charges in Asia, for example, you'll find that actually the CDN is a little bit cheaper.
Wow.
And so that's a really good deal at that point. So CDN, awesome. I love it. You should love it too. But you got to pay for it starting July 1st.
Wow. I tell you, that's those CDN characters. All right, Azure Miscellany. I love this.
Yeah, I think it's a good name for a blog. This is by a guy named Joe, and Joe is talking about his web role.
This is Joe the plumber.
Crashing. It doesn't say it here, but I think we can safely infer from the content of the post that that's who it is. Basically, he was looking at this application where every once in a while the web roles would just start doing really poorly, and then exceptions would get handled by the web role. So he was never actually getting to debug this thing by looking at a crash dump, which is one of the things Diagnostics can diagnostically collect for you. But he couldn't get to it because it was being trapped. But yeah, I thought so. It was being caught by this, by the top level exception handling in the web role. So he actually wrote some code in here, which he shows that basically sees that it's this exception that he wants to sort of create a crash dump for, and goes ahead and crashes. Just it goes the whole way up. That way, the crash dump actually gets created. Diagnostics can pick it up for him. He can take a look at it offline, figure out the issue, and it's such a teaser. It's this whole thing. It's like this mystery of what's going wrong. And at the end, it's like, oh, the cause was some dodgy server-side image resizing we were doing.
Yeah.
So you don't even really get to see what the bug was, but I guess that's kind of beside the point. Because the point is, how can you debug this sort of issues? And you do it using the wonderful Windows Azure Diagnostics, which brings us to our feature.
The feature, we're going to get very diagnostical on you during this section. And I think probably the best way to proceed is really to kind of diagram what we are doing today. So you can kind of get a feeling and bearing, if you will, of where we're at in the world when we talk about diagnostics. To do this, I'm going to draw a picture that might look familiar, and that is a box that is your code. Your code runs in a VM. So in Windows Azure, you have an instance. Within that role, you have this instance that's running your code. Now, the code has access to local resources, and those local resources are like disk, for instance. So you have storage on the actual VM itself. Now, when we start up this instance, by default, if you took one of our templates that we delivered after PDC 2008, in the onStart event, you saw something called diagnostic monitor.start. And what that does is it actually starts, I will say our diagnostic monitor, abbreviated DM here. And this process starts up and it starts collecting data. Now, the logical question you might have is, well, what is it collecting? The purpose of the diagnostics monitor is to put you in control of the different aspects that you can monitor in your application. So we have various things that it can work on. Those things are the event logs, just the same stuff you would do today. So event logs, you would look if your application was writing to them, for instance, or if there was a crash, you would actually go to the event logs and look. Trace messages, so trace, debug. When you put your trace statements in your code, you're going to be generating these. At the same time, you're going to have things like your performance counters. You might have things like log files, and this can be IIS logs. It could be what we call the FREB logs. FREB is great. It's the failed request event buffering. They might have actually called it something else, like in the IIS. It might be failed request tracing or something like that. But the FREB is a great capability built into IIS, which we have in our worker role, that allows you to essentially buffer up the request, and you specify some parameters to indicate whether or not you consider the request to be successful or a failure. And notice I'm not saying that it's not a case where every crash or something like that, FREB gets invoked. What you do is you specify conditions where you want FREB to log the request. So it could be something like you want every 404 or every 400 or every 500 range to be considered a failure. Or it could be just the page took too long to load. So you can say anything that took longer than, for instance, 200 or 2,000 milliseconds, 2 seconds, go ahead and log that. FREB will be invoked. It writes to disk. Well, if you want to retrieve those, you actually need the diagnostic monitor capabilities to pull those off the box. IIS, of course, writes its standard logs. You want to get to those. And then we kind of have a catch-all. Well, actually, there's two more. We have a catch-all in here. I'll just say logs. And these are existing applications you might have today. So it could be a PHP app. It could be something you have in Java, or it could be an existing .NET app that logs to the file system normally. You don't want to have to change those to really understand the environment that they're running in, so you can actually continue to have those logged to disk locally, and then you can have the diagnostic monitor those and pull those down. And the last little bit is infrastructure. These are our infrastructure logs. Did I spell that correctly? It looks kind of correct. Infrastructure.
Looks plausible.
It's not infrared, it's infrastructure. The infrastructure logs are really the events that are going on internally in Windows Azure, so like the heartbeats that are happening, what's happening in your instance and role. The reality here is that I've never really found a great use for them as a developer. It might be something I would look into if there was an actual problem, some troubleshooting, and I kind of wanted to know what was going on in what the Fabric controller was doing, for instance. But the reality is this is pretty chatty, and you might not need to monitor this that often. So anyhow, here are the things you can monitor. And how does this work? Well, your code is generating some of this, so like trace statements or logs, and it's logging it right to the local disk. And the diagnostic monitor is it's monitoring the event logs, it's monitoring things like the perf counters, and it's going to go ahead and buffer these to disk as well. At some point, you need to get this information. You'll notice everything here is being buffered to disk. At some point, you want to get this information out, and you want to pull it into a location you can retrieve. And this could be potentially a lot of information if you're, for instance, generating 25 performance counters every second. So it would be really great if we could move this massive amount of data locally stored into something that is visible and can hold lots and lots of data. Sounds like, I don't know, we might have a service for that. So indeed we do. Depending on what it is, we will move it over to blobs or to table storage. So for things like log files, these are going to get transferred into blob storage. And things for like performance counters and trace messages, we'll go ahead and transfer these into table storage. Now the deal here is that you can control this. By default, we're not going to take anything and push it into your storage account because there's a cost concern for you. If you were generating gigabytes of data, you would actually incur the storage cost plus the transaction cost of moving that. So we're going to put you in control of this. And there's two methods that you can do. You can either on-demand push this, so that's the case where your code's been running for a while and maybe this dies. You want to go back and look in time and see what happened across your service. You can go and say, on demand transfer everything that you have in your buffers. And you push it out. So we have this on demand transfer. And the other, of course, is scheduled. It could be the case for capacity planning reasons that you want to get some regular performance counters and take a look and see how your service has been behaving over some period of time. What you want to do is just set up a scheduled push, like every 5 minutes or every hour or whatever it is, push that data out into the respective table or blob storage. And again, it depends on what you're looking to do here. For capacity planning, you're probably interested in performance counters and maybe some of like the trace debug statements. But in diagnostic mode, if you're trying to diagnose what was happening, you're probably going to be interested in event logs, the IIS logs, and etc. The great thing is all of these are configurable individually. So you don't have to log everything, and you don't have to choose, for instance, that I'm going to set aside a buffer of 4 gigabytes or whatever it is to begin. You don't have to choose that all of these have to fit. You can actually partition out the buffer on the local disk. So by default, you'll say, I have 4 gigabytes of overall buffer. I want to dedicate, only 100 megabytes to event logs. Perf, I think I'm going to do 2 gigabytes. Logs, 1 gigabyte. And I'm not going to monitor this, and I'm not going to monitor these. You can just choose how you want. Now, the final bit to this whole magic is things change over time. So you have your role running, and it's doing stuff, and eventually you decide, well, you know what, I want to look at what happened, or I need a different performance counter that I need to look at and see how it actually, impacted my service over time. So you have to be able to configure this remotely. And it turns out you can do that. I'm going to diagram how that works. So today, I'll just get rid of this. Today, when your diagnostic monitor starts, it goes out and it looks into blob storage for a little bit of metadata. And this is an XML file, the whole angle bracket game, that contains the configuration settings per instance by deployment. So if you go look, there's something called a WAD control container in your blob storage account once this diagnostic monitor starts. It starts up and it looks for this configuration file. If it doesn't find it, it goes out and it creates it on the first go with some default settings. Now, subsequently, it will pull this. So it's going to go out and it's going to look at this file every 30 seconds or something like that. You can kind of configure the pull rate. But it's going to go out and it's going to look in the blob storage for this particular file that tells you the settings. Well, if you manipulate this file per instance, you can actually reconfigure what your diagnostic monitor is doing. So you can tell it to do new perf counters or stop perf counters. You can change the deployment schedule. You can do all those things. And we provide a set of APIs, which you'll find in the Microsoft.Windows-Azure.Diagnostics assembly, that will allow you to go out and actually update this. So there's some sample code out there on MSDN that will allow you to go out and remotely configure this. So the only thing you need to be able to do is see your storage account. You don't have to interact with the role at all. There's no code in your app that needs to do anything. You can remotely go manipulate a file in blob storage, essentially. It will pick up those changes, and then reconfigure itself. And that, in a nutshell, is how you remotely do this and configure. Well, obviously, not everyone's going to be writing their own code every time in order to do this configuration. So we've actually produced a set of tools that will allow you to do this. And one of the things I want to show here is the Windows Azure MMC. I'll just bring that up. And this MMC was something released a few weeks ago.
Pretty recently.
Yeah, pretty recently. It's actually been in development for quite a while. It was since February or into January. This thing's been ready, but we published it out, I think, in May. And what it does is it is a UI that's built on top of the Windows Azure Service Management commandlets, which are those PowerShell commandlets that we've talked about in the past. Those commandlets wrap the Service Management API. They also wrap the Diagnostics API that I was just discussing. So this MMC, in turn, wraps those commandlets and sends all the commands that you enter through the UI, through the commandlets, and then on to Windows Azure. So what I have here is, if you look on the side, I have my hosted services. I have the actual hosted service in running. So in this case, my Azure storage. And under there, I have my diagnostics capability. What this is a view into what I'm monitoring. So again, these match up pretty nicely with what I was talking about, my file-based logs. I'm going after my failed request traces, my log files, and crash dumps, which that blog post was talking about. Here's the infrastructure logs. In this case, I'm actually not monitoring those. As I said, they're pretty chatty. The Windows Azure logs, these are actually your trace statements. So these are, trace warning, trace info, and all that kind of stuff.
Debug.writeline.
Yeah, and trace.writeline, exactly. And then Windows Azure event logs. These are your standard system application. Steve, I had a pretty good blog post on how to filter those. So if you do have some syntax in there, you're going after a particular node, check out Steve's blog. You would put that same syntax in here, and you would be able to then monitor the event logs. And last but not least, of course, performance counters. The performance counters that I happen to be monitoring here are the processor, memory available, some of this NIC interface for bytes sent and received, committed bytes, my ASP.NET application total requests per second, things like that, just typical stuff you'd want to do. Now,
so these are the settings for collection, right? Is that
these are the settings for collection. So once I configure this, my role is now buffering all this stuff up locally.
But it's all just local.
But it's all local. Right. It's still on the disk at this point. What you have to do is you have to now transfer it. And as I said, like in this case, you can see that I have a scheduled transfer every 5 minutes. And here I have a scheduled transfer every 60 minutes. So these are individually transferring that information out of my role into blob or table storage, depending on what I'm transferring. But I've already set up a schedule. Alternatively, I can go ahead and hit transfer now, like all roles or this particular instance, and just retrieve that information out of that particular role, everything it has that's been buffered up. Now, some of the things that it probably bears talking a little bit about, and Steve and I have been discussing this to some extent, is when do you use this diagnostics capability, and when do you use, we showed like the service bus trace listener. Steve has demonstrated his printf style debugging, and if you paid close attention to the last dancing episode, swingify.net, you saw that Steve had a trace listener that he had in his code as well that wrote directly to table storage. And, we had this conversation, and I think, the motivation of why you wrote the trace listener to table storage seems pretty clear. You need instant.
I didn't want to wait for that on demand, but I just wanted to click a button, see it come out.
Yeah.
I also didn't want to have to worry about, nothing got transferred yet, and then I crashed, or things like that. And so, for me, it's been handy when I'm just debugging something for the first time or whatever, put it up there and have it just immediately logging something so that I can pull it, or using the service bus version of that, so it just gets pushed straight to my client. So you get that like immediate feedback, which is nice, particularly when you're first writing something and you're first debugging it and just want to see, does it work or what's it doing.
I like to separate the idea of debugging versus monitoring.
Right.
Like for debugging purposes, this actually might be too slow for developer satisfaction, because we're going to buffer this locally, and then you're going to have to ask for it on demand, or you're going to have to set up a 1 minute scheduled transfer. If you're developing something, 1 minute seems like an eternity. I mean, it's funny that you say that, but it does. It seems like an eternity.
It's harder then to correlate with things like I pressed a button in the web page, or I just sent an email that's supposed to get received there or something. It's easier when you can sort of see it in real time.
Yeah.
And you get a better sense of the timing than looking at timestamps, because you just see the message pop up immediately. It's a lot easier. It feels a lot more like that debugging experience where you're just stepping through the code, right? I mean, you're getting sort of the instantaneous feedback.
The response.write of Windows Azure.
Yeah, but as Ryan's been pointing out to me, right? That's the printf response.write alert. That's what I use when I debug stuff. But Ryan's been pointing out there's a difference between that and the ongoing maintenance monitoring. I just want I want to keep an eye on how things are going over time. And there, it's not like I'm sitting there waiting to look at it. I just want to make sure that as that buffer fills up, it gets transferred, and I want to do it in an efficient way. So I've written this trace listener that writes straight to tables, and it doesn't buffer anything. It doesn't use batch transactions, whatever, and it will actually slow down the app because it's waiting every time I debug trace anything. It's waiting for storage. It's synchronous and it's one at a time, and that's not a scalable way to do this long term. It's not really what you want. Windows Azure Diagnostics is better suited for that. I'm going to collect things as they go. I'm going to buffer them locally. It's actually sort of a best effort on how much. Then I'm going to transfer what I can based on the buffer size and what I've been able to capture. So it's not going to interfere with the running application. It's not going to slow things down. It's very efficient. But you're going to get this information sort of pushed out as you go, or just every once in a while when you see, something just went wrong, let me just grab whatever's in that buffer now.
Or someone reported the website seemed to be running slow. Let me go look at the last hour of data that I've been collecting and try to figure out for all the instances what was happening. It's totally different than you're writing an application, you're trying to debug it, and you want to know what the heck is happening right now. That is really a different thing. And I think the once you go into production and you have this application up and running, the diagnostic capability here is really you're going to be using to look back in time to see what happened, or you're going to be using for like capacity planning purposes. How do you know how popular your service is if you don't have a way to look at the performance counters of like requests per second or memory usage or whatever it is, CPU utilization, who knows? How can you do that if you don't have a way to retrieve that? And because we allow you to buffer it locally in some set, you can buffer as much as you want, essentially, or as little as you want. And you can change that over time as well, which allows you to change your decision. Like if for some reason, like you weren't collecting enough information and we were aging it out of the buffer, you can change the buffer and you can just make it bigger and then store more information. You can also, some of the things that I should point out is, you can also, like, for instance, buffer everything local. You'll notice that we have, like, for our let me go look back to this diagnostics node here. If you see here in the Windows Azure logs, you'll see that we have this scheduled transfer log filter level. Well, when we collect the trace statements, you can actually filter them. So you can actually say, collect everything, like verbose, just trace it, buffer it locally. But if something went wrong and you were looking back in time and you only really want the critical and warning, you can actually apply a filter on the transfer so that you're not sending gigabytes of verbose crap that you don't care about. You're just getting to the meat of what you really want. Use
so
these liberally.
So you can collect it all in case you ever want to dump the whole thing, but you don't have to dump it all.
Which is fundamentally different than putting a trace listener in there that's going to just absolutely nail your table storage, right?
Exactly.
So we just wanted to kind of clarify that, make sure that there's no confusion on when you would use one and when you would use the other.
This is the robust, scalable one, and mine is the I'm just writing code. I want to see what's going on.
And the incredibly useful I'm debugging my app and developing it live kind of thing.
Go ahead.
Yeah, a few more things on this. I would say when you get this up and configured and running, one of the things that you need to keep in mind is that if you're doing it from a performance planning perspective, you probably don't want to have this thing buffering data every 2 seconds or taking performance counters every 2 seconds, because that information is actually kind of meaningless in a larger context. What I'm trying to say is that let's say that you did need to respond to a sudden influx of traffic. Okay, it takes right now about 15 to 20 minutes to initiate a new instance. So it doesn't do you a lot of good to buffer everything every 5 seconds if your reaction time can only be every 15 minutes. Similarly, you're billed on an hourly basis. So you wouldn't want to write any logic in here that like grabbed all this information and try to scale up and down within 20-minute windows. You should think about
might as well leave it for the hour.
Might as well leave it for the hour. You should actually take a look at a snapshot at an hourly time. So for capacity planning purposes, you need to look at this data just a little bit differently than you might for debugging purposes, and that's really the.
You also want to
only
make sure
point
you're aggregating at the right level, because
Yeah.
looking at those, hey, this second someone clicked a button, so we spiked to 100% and then dropped back down, isn't really useful. The question is, what's sort of the sustain rate, and you want to see the average over time, because it's easier to sort of crank up the. Look at fewer samples and then aggregate them and get a better picture of what's actually going
and one
on.
of the things I should also point out is there's an analysis node in here in the Windows Azure. So once you have this data being collected, you can actually go out and for this storage account, I want to retrieve the last 90 minutes. And go ahead and get this. So you would actually apply filters here. It'll go out asynchronously, search for all of this data that's been collected if it's been transferred into storage. And you see in the last 90 minutes, I had 8 logs show up. If I open those up, I can see the actual log files, the IIS logs, and then open them up and you can see what actually happened in IIS. And now similarly, you can open this with Excel, and you could do that for performance counters. And we did that because Excel seems to be a pretty good general purpose tool.
It's nice to
in terms
graph and do, it's sort of
pivot,
limited queries.
Yeah,
sort of
pivot
things.
tables, and you could do all those things. So you can also create your own plugins in this particular application. You'll see that these particular ones here that are in the dropdown, these viewers themselves are all been implemented as plugins, which, pretty sophisticated, open up Excel and import a CSV file essentially. But you could write something, and we have samples out there that show like how to create a WPF viewer that can do the graphing and can do all those things for you. Additionally, we'll continue to invest in tooling to help you really look at and make sense of the data from a performance
Because there's a bunch of raw data, and it's sometimes not that easy to figure out what to look at or how to view it. And so tools like that are gonna be cropping up, not just from us, but from everyone in the community, I think. And they're gonna be really useful. But the good thing to know is that you've got all that raw data and that you're collecting the things that you want. And then you just need to figure out sort of how are you gonna look at that. And it's sort of a data analysis, data visualization problem.
Exactly.
And there are lots of ways to solve those. One way is bring it in Excel, highlight the whole thing, graph it, things like that, which are pretty easy to do with what we've got now. But even better stuff will come along. Make sure with all that raw data that you delete it every once in a while. So that's the other. I just want to point that out. Ryan sort of already mentioned it, but I want to make it really explicit that nothing gets deleted in this scheme. If every 5 seconds or every 5 minutes, either you're transferring a bunch of stuff over to storage, it's going to stay there forever unless you go and delete it. So that may be okay. At 15 cents to store a gigabyte, you might not really care for a long time. It depends sort of how much stuff you're transferring.
And how many instances are doing it.
And how many instances are doing it. But think about it, at least do the back of the envelope math and figure out how much stuff am I dumping? How long do I want to keep it? Maybe I just want to keep 1 month worth of data or something like that. And then run something that deletes those things. That could be part of your application in a worker role that occasionally deletes those things. Or you might just, once a month open up one of the storage tools for that and just delete a bunch of the old data. But it is your responsibility to figure out that part of it. The diagnostic tools here never delete anything, which is, I think, what you want them to do. They don't go destroy any of this data, but they push it in periodically.
Yep.
So is it that time? It feels, I've got this dread, this sense of dread.
It is.
And I feel that means it's time for the tip of the week.
Yeah, well, when I think about diagnostics, I think about, health monitoring and troubleshooting. And nothing says health like 1940s, 50s, and 60s PSAs, those public service announcements.
Yeah.
The black and white ones.
Yep, it's got to be black and white.
Got to be black and white, and it's got to have a really cheesy announcer voice guy.
Yep.
Telling us about some crisis in public health.
Yep.
To introduce tip of the week.
If we didn't have that, it really wouldn't be tip of the week.
No,
Just
not
wouldn't
so
feel like
much.
tip of the week.
So we'll see how Bob handles this.
So with that, here's a diagnostical introduction to the tip of the week.
Do just a little bit more than you think you can, and you will be off to a good start.
Okay. Tip of the week is
How to mess things up.
Yeah,
That's really what this tip of the week is.
how to make sure you're not messing things up with
That's a more
diagnostics.
positive way to say it. Yeah.
So one of the things that you will notice when you start your role or when you create your initial template in Windows Azure and Visual Studio in particular is you'll see the on start, and you'll see a diagnostic monitor.start, and then one of the parameters to it is a connection string name. That connection string is diagnostic connection string, right? If you go look in your configuration file for this and look at the config settings for that given role that you're in, you will find by default, use local storage equals true.
Yep.
Now,
use development storage.
Use development storage, correct. So the development storage is literally you're logging against our development storage emulation.
So it's pointing to localhost colon 10,000 for blobs, 10,001 for tables, I think. Right, which is great when you're running locally, and that's why it's sort of set up that way. That's the storage account you have when you start off and you're debugging in Visual Studio.
Now, when you deploy this, guess what? Localhost is not a valid endpoint for storage.
Yep.
I didn't know if anybody was not aware of that, but it is actually not. This comes up because people will actually see errors sometimes in the debug statements or things like that they have, or they might see in certain situations, like if you tried to transfer storage, you might see your role crash. And the reason is because you're pointing to a resource that doesn't exist. And the tip here is to always do one of two things. I would say always turn on the diagnostic monitor and point it to a valid storage account. But you might not care. Maybe you just don't care at all.
If you're really not using it, if you didn't notice that it was still saying use development storage equals true, then maybe you're not actually using it at all, which is totally fine. We will be a little offended, but not too offended. In which case, comment out that line. That's it, right? You just there's one line that says diagnostic monitor.start. If you just comment that out, we never launch that diagnostic monitor process, or rather, you never launch it because it's your application code that does that. So you'll never launch the diagnostic monitor, which means it won't try to do a thing. So it doesn't care what storage account you're using, or whatever. It's never going to try to do anything, and that's a safe way to do it. It's probably a better idea if you actually want to use diagnostics to just point it at a real account.
I would point it at a real storage account, and the deal is because by default we're not transferring anything into cloud storage. I want to be clear, everything is just buffered locally. You need to go in and configure it to either automatically push or ask for it to push on demand.
Right. So there's no harm to pointing to an actual
absolutely
storage account.
No harm.
It's not going to do anything.
Right.
And then that day when you go, oh, it'd be really good to take a look at these perf counters, you'll just be able to go configure it using one of these tools, or just by modifying that blob in storage.
Exactly.
And now it'll actually transfer something. If you didn't do that, if you commented out that line, or whatever, now you've got to go upgrade your code. You've got to go deploy a new version that turns on diagnostic monitor before you can actually do it. So think ahead, point it at a storage account.
And then the last tip in this is if you do put in a connection string, in which we recommend you do, it needs to be HTTPS.
Yep.
Well, that's not strictly true. If you don't choose HTTPS and you choose HTTP, then you have to go configure the diagnostic monitor to allow unsecured connections.
Set a property that says it's okay if it's not HTTPS.
So it's just way easier to use HTTPS. And what's non-intuitive is that your role will start crashing if you put HTTP and you didn't configure it to allow it.
When you call diagnostic monitor.start with a connection string that is not HTTPS, and you haven't set that allow insecure endpoints thing, it'll just crash right there. An exception will get thrown right there. Because we don't want you to run your app without having the diagnostics on that you thought you would have, right? So it just dies right there and says this is not allowed, this is not a valid connection string. Same thing would happen actually if you had a totally bogus connection string. It's sort of the same thing, that starting that will just completely fail. To you, that looks like I uploaded my code, it said initializing, then it said stopping, and then it said initializing, busy, stopping, initializing, because it's crashing every time it starts up. You can point the diagnostic monitor at cloud storage even when you're running locally.
Absolutely.
That's a good idea. We've talked about this. This was a tip of the week way back when in like the first or second episode, was that you should do that. And if you do that, you'll catch this thing early because you'll point it at this connection string, and if it's an HTTP endpoint, it'll just crash right there. And since you're in Visual Studio, you'll break into the debugger, and it'll be much easier to spot what the issue is. So try your real diagnostic monitor settings locally before you go deploy, and that'll save you much of that headache, I think.
And the thing that might throw you a little bit if you do what Steve is saying is you put the cloud storage settings in, but running it locally. The deployment IDs are a little bit different than what you would see if you were running in the cloud. So in the cloud, you have a deployment ID that looks kind of like a GUID. In the dev fabric, you don't. It's like deploy parentheses some number, that's
low number
that's incremented after you do more and more deploys. So you're going to see
so
that.
The data will look
so
a little
the
bit different,
data looks a little bit different, but otherwise it's the same.
Yeah.
That's it.
Yeah, that should cover it. If you do those things, you should have some success with the diagnostic.
And if you
monitoring.
have some tips or tricks that you've done with our diagnostic capabilities, or you have other troubleshooting tips that you have as well, please share them with us on our Twitter account at Cloud Cover Show on the Twitters, and let us know about it. If they're really good, we'll probably follow up in another show and even mention them here.
Yep.
With that, thanks.
Bye.